As far as we know, our planet, Earth, is the only one in our solar system known to sustain life. In all of the discoveries made during space exploration, one thing sets us apart from the other planets: water. Water supports all life on Earth and is essential for the vital ecosystems on which we depend for our very survival. Life as we know it could not exist in the absence of water. But fresh water is a limited resource, accounting for only a small fraction of the total volume of water found on planet Earth. We use water daily in our homes, for agriculture, and for industrial processes. This daily use produces wastewater, which is largely untreated before being deposited into our environment, with negative consequences on human health and the environment. Yet in nearly all instances with adequate treatment, the very same wastewater can be reused and consequently produce many benefits. Wastewater has traditionally been regarded as undesirable, even offensive byproduct of domestic, agricultural, and industrial activities. According to King Willem-Alexander of the Netherlands, there is no such thing as wastewater, only water wasted. Recycled wastewater is now increasingly being regarded as a very important resource with many benefits: economic, environmental, and health. Some of us may already be recycling water on a small scale in our homes for irrigation of small gardens, cleaning our yards, and for use in toilets. On a larger scale, some of our hotels have wastewater treatment plants and robust water recycling and reuse programs.
At Sandals Houston, we have an activated sludge wastewater treatment plant, and essentially a general basic breakdown of the process is that the water, the sewage that comes through our pipes will go from a lift station and is pumped into the plant, into an aeration tank. It goes through a few different stages where the sewage is then put into a clarifier where sludge is separated from what's called supernatant or clear water. And then that water is then stored, chlorinated as well, and that is the water that ends up being this treated wastewater that's useful for other purposes, for reuse. Our treated wastewater is used entirely for irrigation of our grounds and landscape. We do this primarily at night and in the early morning, and that's an important thing to do in terms of conserving water, because of course in the heat of the day you could have evaporation of water, so you want to water your plants when you'll be able to optimally get as much use out of the water as possible.
Apart from the obvious cost savings, the programs also minimize the environmental footprint of their operations and contribute to the preservation of our natural environment and human health.
Having your own treatment plant, you avoid having to pump your sewage to an off-site treatment plant, which could be some distance away, and that does require a lot of energy, large pumps as well, to get that sewage to the appropriate place. So we are certainly making cost savings, as well, of course, we have the environmental benefits that come out of having this treated wastewater available to us on a daily basis to treat the plant.
One sector which is heavily reliant on a reliable and steady supply of water is agriculture. The issue of farming, in particular pig farming, has led to a special focus on exploring practical approaches to wastewater management.
Pig pens use a lot of water for management, for maintenance, for cleaning. And after the cleaning process, that water is dirty, it's contaminated, it's polluted, especially with bacteria from the animal feces, mainly being E. coli and coliform. So our main objective is to clean that water so it could be suitable enough to redistribute to the rivers, to the streams, and to any waterway.
To that end, they have been reworking an established technology for treating effluent from pig farms, biogas digesters.
The main focus of the biogas digester is to clean, treat, and improve the water which is released from the pig pens into the river or streams or waterways. Water pollution and water contamination is not always visible, meaning it's not only trash, plastics and stuff that dirties the water. We have chemical pollution, we have bacterial pollution. So a big part of the biogas system is to improve the quality of water which comes from the pig pen and goes back into our waterways.
The modified biogas digester program is aimed at addressing the wastewater issue economically by bringing the biogas digester technology to within the reach of farmers who would not necessarily be able to procure and or maintain the conventional systems available outside the local market.
The biogas digester is a very, very good thing, which it helps on many, many ways. I can use it for my lighting stove, right, and then could cook my food and everything on that. Plus I cook the pig food on it also. And then I picked up all the manure from the process that I could use it in my vegetables. Right, it helps them to grow much better. I use very little fertilizer.
This has typically been more efficient with larger farms, but modifications made under this project has seen some promising adjustments that make the construction cheaper and applicable to smaller farms, with the potential for it to be increased in a modular fashion, with the increase in small farm size or activities, and all from locally available materials.
We want to have solutions that are sustainable, and you want a solution that the farmer can not only afford, but that the farmer can also maintain. So from that, we came up with different variants of digesters using recycled materials or readily available materials. So the customized system we have up to now is using recycled 1,000-gallon tanks. So on our recent adjustment to the St. Lucian digester, we got partnership from Harris Paints. So they donated the tank, which we incorporated within the system.
Biogas digesters have the benefit of minimizing a negative impact of wastewater from pig farms, while also generating energy that the farmer can apply to processing, lighting, and heating at his farm or for establishments nearby.
As a byproduct, we produce methane gas, which is usable for heating, cooking, many purposes. Running a generator, we could do many things with the gas. The process of making methane gas is basically a process of fermentation. So the water is collected in a container and it is allowed to ferment for a couple of days, maybe 2 weeks. Through the process of fermentation, most of the bacteria are eliminated, killed, destroyed. So we already have an improved water quality, right? The whole intention is to reuse that water. That water, apart from the majority of the bacteria being destroyed, it is still very rich in nutrients. So we are hoping that we could take that same water and use it for what we refer to as fertigation, which is the mixture of fertilizer with water for the plants. It's called fertigation.
This digester, the first of its kind in St. Lucia, will serve as model for the island and wider Caribbean. The reuse of wastewater can ultimately be seen as a climate change adaptation strategy that serves well to make our country more climate change resilient. Having highly treated recycled water available for use, even during times of drought, water scarcity, is valuable for the agricultural community as they can use it for irrigation. It is also a resource that can be used by the fire service and construction companies. The most obvious economic benefits is that of a lower water bill. Domestically, each of us can do our part to protect our limited water resource. Water conservation is something we should practice every day and all year round. recycling your grey water, water from showers, laundry, etc., for things like cleaning the yard, watering the lawn, flushing the toilets. Rainwater, a free water resource, also goes to waste when we don't use it, because we can put it to use by harvesting it to be used in our gardens and yards, to wash vehicles and watering lawns, among other things. For wastewater reuse to be considered as a viable means of addressing pollution, mitigating climate change, and deriving economic benefits, it must all include systems for the protection of human health. We must be conscious of how we use water, with a view to reducing our use and reusing as much of it as possible.